So in this particular case, there's a couple interesting things happen. So we broke down the consumers. So consumers grouped in consumer groups. So those are consumer groups. It's going to be consumer group 1, consumer group 2, consumer group 3. And those consumers can run in absolutely independently. So they don't need to know about each other. They don't need to do anything with themselves. And the cool thing, and one of the difference between messaging system and Kafka, is that Kafka will not push this to your systems. That's not how it works here. Instead, consumers will get this information from the Kafka. When the consumer is ready to receive new information, it will request this information. Similar how Mommy Bird will provide you with tasty worms to baby birds. It not shove it in their throats. Actually, baby birds will consume it as they can go. That's a huge difference. So in this case, consumers don't need to have some of the there's a technique called back pressure when the one system can notify another system that it's not ready to read these messages. And the back pressures was very important in situations where you're dealing with the messaging system, and with this messaging system you actually need because like if you not keep up with the processing of these messages, you will be overwhelmed. With this case, you don't need to do this. Consumers will read the data at their own pace. Some consumers can do it faster, some consumers can do it slower. Information will be stored already. And producers won't be able to affect the consumers. They totally independent. And this buffer that we see here, let me use different color here. This buffer known as Kafka will be handling, it's like your back pressure by design. So regardless of the speed of producers, they cannot overwhelm consumers. So that's pretty cool piece of design. And producers are pretty simple. So producers just writing data into the end of this file, and the consumers reading from the beginning of this file. Also, along the way, it will store this offset somewhere. Producers and consumers can be written in different languages. There are tons of different languages, like native producers, consumers available. So your producer can write the data in, say, Java, and you can read this in C#, for example, or Golang. Kafka itself, written in Java and a little bit of Scala, and runs on JVM, but your clients can be anything else. There's also the project called REST Proxy, Confluent REST Proxy, that allows you to produce messages through REST and using curl as your producing consume messages through REST and using curl as your basically application. Now, it's good stuff when we can do sending messages back and forth. What about processing? Like if we need to do any type of message processing, because at the very beginning over here in this slide, I showed you that it's actually, it's good that you capture all these events, but it is important to have ability to process those. And in this particular case, as you can see, there is a small database over here. Many cases, when you need to process these messages, you don't need to remember what you did before. So in this case, you have to deal with the thing called stateless stream processing. Operations like filtering, operations like simple transformations, they don't need to know what happened before. They don't need to know what was the result of this computation. So it's easy. That's something is easy. Like you can implement filtering logic on simple consumers. However, in the use cases where you need to do things like counts, like any type of aggregation, you need to remember what happened before in order to add this to results. So there should be some storage. And when we start talking about stateful stream processing, and stateful stream processing is important thing to understand how it works. It will require storage somewhere. Somehow results needs to be preserved between runs or between the step of the processing. Let's talk a little bit about processing. I'm not going to go like very deep here on the processing because the purpose of this presentation was just give you a general overview of Kafka and overview of the technologies that are available of Kafka. So the things that Kafka has out of the box, it's producer and consumer API. The things that I just touched a little bit in this application. So think about this: the producer and consumer as the foundational API. Think it was about assembly language of Kafka. So you cannot go lower than this producer consumer API. Of course, you can implement your own client and implement Kafka protocol to understand this. But you need to deal with the messages on the very low level thing. So you need to know what you to do with message, how to properly handle processing of this. You don't want to run the processing in the same thread that you're running, that you're consuming messages. In this case, you can create a timeout, and based on this timeout, the consumer group controller can decide that, oh, okay, probably, this baby bird is doing something funky, so we need to like throw it away. So that's the foundational API. Next thing, Apache Kafka includes a framework, a Java framework called Kafka Streams. Kafka Streams framework is based on consumer and producer. However, it provides higher level abstraction methods that allows you to deal not only with individual messages, but deal with streams. So in this case, the concept of topic will be transformed into concept of stream, and you do stream processing using this Kafka Streams things. And now you have ability to access APIs with more higher level semantics. If you need to do some sort of transformation, you'll have a method that map. Many of you, if you do any Java development or maybe even Scala development, there's concept of Java utils in Java 8. Developers of JDK introduced a streaming API that allows you to work with your collections in a streaming fashion. And Kafka Streams has very similar concept that many of you know from Java util streams. Now, there are not so many, or there are many not Java developers out there. There are many people who want to do stream processing, and specifically they want to do stateful stream processing. And those people don't want or don't need to think about Java and how to compile this application, deploy this application, etc. They want to build a stream processing pipelines. And KSQLDB is a streaming database that was developed at Confluent, and it is like source available system. You can use this for free with like any like Kafka installation, and using SQL syntax to write your stream processing applications. KSQL supports stateless processing if you need to just do simple transformation mapping, or like change one format of the data to another, or it might have stateful stream processing as well. So that's something to consider. Again, if I would say that where to use consumer producer API, Kafka Streams, and KSQLDB, I think it's all about flexibility versus ease of use. If you are writing framework and you need to have access to lowest possible level without dealing with the actual like wire protocol of Kafka, you go with the producer and consumer API. Now, if you're Java developer or Scala developer, you might want to explore Kafka Streams API that allows you to write your application, but still you need to deal with the deployment of this application and the maintenance of this application. But if you need to deal with stuff around just like writing stream processing application, you can use ksqldb. It's also available as a managed service. It can be just used as a kind of like a serverless stream processing application. We talk about the stream processing specifically in the chapter 12 of our book. We brought example that we showed you how we can use stateful and stateless stream processing with the transaction processing, plus how you can combine usage of Kafka streams and ksqldb and the consumer producer. So your producer API can be used in your application to produce data, Kafka streams to process, and ksqldb can be used to do, I don't know, some sort of reporting, or like have a very quick joins and all this kind of stuff. I would like to recommend another book that also available at Manning, called Event Streaming with ksqldb, with Kafka streams and ksqldb by Bill Bijak. He's a former colleague at Confluent, and I was huge fan of his work way before I had the honor and pleasure to work with him at our developer relations team at Confluent. Bill has a very good sense of describing things to people, so or explaining things to people. I highly recommend this book. It's one of my favorite books.